Okay. Now let's revisit the CFA again.
Yes, but you don't have to put the
Okay, we'll apply the CFA to TM dataset. So we need to generate 5 factors. Right, 5 factors. Okay, now let me just stay here. You can follow my demonstration step by step. Open the JASP again, and we can delete this one. We can delete this one. Now this one. Now this one. Another one. Don't save. About this one. Yeah, this one. We can delete CFA. I already did it. So we use the same data set of TM. The same data set TM. And make sure all the indicators or all items, the scale have changed to the item have changed to scale level, all scale level. Now select the factor analysis and select confirmatory. Confirm, we mean confirm with theory. We confirm the theory. Okay. So the first one you can just type in USEF US no I've changed typing USEF why okay USS. So you bring in the 5 items. For usefulness, it's perceived usefulness. Okay. So this is the first factor. Then click plus sign. Click plus sign to create the second factor called useful, easy of use. Easy of use. Easy of use. Then we select another 5 indicators for easy of use. Okay, that's the second factor. The third factor, I guess, is additive, so ATT. And select 5 indicators for additive toward technology. Now, good. Okay, we have finished 3 factors. Now, the 4th factors will be behavior intention, right? BI. Behavior intention. So we have 3 indicators for behavior intention and move to the right. The last factor is use, actual use. So select type use. And from the left-hand side we have 4 indicators for use. Okay, good. Now okay, we already specified the measurement model. This is called measurement model. Measurement model. Use indicators to measure the factors of the construct. So we have 5 factors. Usefulness, easy of use, additives, behavior intention, and use. Then next, model option, we don't need to change anything. Okay, about the additional output, yes, we need additional fit measures. So check additional fit measures and R square and AVE and HTMT and reliability. Okay. advanced. The left-hand side, we need standardization of variables. So we click all. Click all. Okay, good. Now it's time to take a look at the result. Okay. We use different indexes to measure the model fit. The first one is the chi-square test. The chi-square p-value is greater than 5%. So we have to say something. What does that mean? What does that mean? The chi-square test, the p-value is significant, greater than 5%. What does that mean? Chi-square p-value greater than 5%. What does that mean? Our data or sample that we have collected versus the measurement theory either fit or not fit. If our p-value, you can see that, is significant, even greater than 5%, does it imply the data or sample fit with the theory or not fit with the theory? We need to understand how to interpret. Is fit or not fit? Fit or not fit? Based on p-value?
It's fit.
It's less than.
It's fit.
Now, if we need, okay, got it. We need the p-value not significant. Not significant. We need the p-value that's greater than 5%. But now it's less than 5%. Now the value is less than, it means significant. Significant difference. The sample is significantly different from theory. So it not fit. It means not fit. Yeah. So when the result is not significant, it means the sample data fit the theory well. Got it? So it is KIV here. That's the key. But you can see that the data point is over 1,000, right? 1,000 data points, that's a lot. So chi-square is very sensitive. Chi-square test is very sensitive to the the size of data point because it's too big, too many data points. So usually you will get a significant p-value. You know that? Because we have more than 1,000 data points in our data set. And chi-square is very sensitive to the size of data. So it's very normal to get a result, significant result. It doesn't mean we fail. Because we have another index we can use. Not only this one. Got it? Okay? So we have to interpret the following indexes. For example, This p-value is less than 5%, so implies significant. Okay? P-value, this is significant. It means not fit. It's different. Data is different from theory. So we need to apply another indexes. For example, we need to report this one. CFI. When CFI above 0.9 is a threshold. It means the model fit is good. Okay. So we have a lot of also this one. TLI also need greater than 0.9 or 90%. Okay. You can see NFI, NNFI. Okay. That's also greater than 0.9. We have many indexes. You don't have to report all of it. You just pick several, maybe 3 or 4. That's enough. Say we reach the threshold, reach the standards. Okay. The model is a good fit. So let's scroll down. Take a look at another information, another fit measures. For example, this one. IMSEA. It should be less than 0.08. That's the threshold. Okay. So it means it's good. It's good. Model fit is good. And SRMR, the smaller is the better. The smaller the value is the better. So example is less than 0.05. So implies good model fit. Got it? So that's the way how we interpret the result. Okay. For the convergent validity, we can check the factor loading here, and one by one. For example, perceived usefulness, all standardized estimate, all factor loading. Now this one is factor loading, right? This column is called factor loading. Greater than 0.7 is better. So all of it, and easy of use, this one is not, it's quite close, but it's okay. How about additive? How about additive? Yeah, above 0.7, right? And behavior intention also above 0.7. And the actual use, the fourth indicator have a little problem. Only 0.4. Okay. But in general, for convergent validity, the factor loading is okay. And we also have to check the AVE. AVE is here. The AVE we usually need to greater than the 0.5. So this one greater than 5%, not 5%, 0.5. So it's okay. But this one is not okay. Use is not okay. Because I think it's these indicators. I think that is the indicator force cause the problem. One way to deal with it is to delete the indicator and perform the analysis again. Repeat the analysis again. Remove that indicator force. And HTMT, the ratio HTMT, we expect less than 80% or 0.8, right? So we can check less than 0.8. So we have called discriminant validity, yeah. So you also have to report conversion validity and discriminant validity. Any question? No problem? If you don't have any problem, let's try to do what? Let's try to apply CFA to different data set. And you have to analyze the conversion and discriminant validity by using the data set study 1. This one. Study 1. Study 1 is from our article on the mirror whiteboard. Okay, study 1. And you can check the material again. You see that? We also, you can find the study 1 data set here, measure manipulation in the study. So now this time, I also give you a few minutes, try to analyze the CFA, but to the different data set. This data set is from the study of unethical pro-organizational behavior is this study. Let me show you. Okay, it's from this study. The role of moral decoupling in the causes and consequences of unethical pro-organizational behavior. Now, you can use just to do it. And let me find the data. Dataset. Let me find the data. Open. Study 1. Computer. CFA. Of course, you have to modify the indicator to the scale level. It's a supervisor UPB mean unethical pro-organizational behavior. You can modify all of it. Scale, 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 scale. When you do CFA, you don't need to put demographic information. For example, gender or education. You don't have to put that. You only put the items or indicator for the construct. Okay? Got it? Remember that. So the age, we don't need to put it into the CFA. Scale, 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 scale.哦，谢谢。我还没试过。全选。你是怎么全选？ 你看，这样网上不能，可能你那个是 Windows 可以，然后在 Mac 上不行。I'll give you, let's say 10 minutes to apply CFA to this data set and try to interpret the result. Interpret the result.